Most FPS tutorials teach you how to make features. Very few teach you how to build a professional gameplay framework, and that becomes a massive problem later in development. Because when projects grow, messy architecture, bad inheritance, tightly coupled systems, poor folder organization, and hardcore gameplay logic eventually turn into broken systems. Massive refactoring, multiplayer problems, animation issues, AI issues, and missed release schedules. In this series, we are building the framework correctly from the start, not just making features work, but building scalable systems designed to survive long-term game development inside Unreal Engine 5. This FPS framework and associated tutorial content are original works created by me. You're absolutely welcome to learn from the concepts, build your own systems, and create your own projects inspired by this framework. All I ask is please do not directly distribute or repackage the framework as your own work. Respect the amount of time and effort that has gone into building this series, and if these tools or ideas help you, please give credit to this channel. Welcome back to the FPS Framework series. If you want to build a real, scalable, multiplayer FPS framework inside Unreal Engine using proper C++ architecture instead of disconnected gameplay prototypes, this series is for you. Much of my FPS gameplay philosophy came from an old era of multiplayer gaming. I learned a huge amount of FPS gameplay and game structure building custom Call of Duty mods many years ago. And honestly, that era of FPS gaming was amazing. Gameplay mattered, teamwork mattered, map knowledge mattered, communication mattered, gunfights felt cleaner, more tactical, and more skill-driven. In part 1, we covered the theory and overall design goals for this framework. In this part, we are creating the actual Unreal Engine C++ project and building the first clean gameplay framework structure. Before we begin, we need a project name, and for this series I chose Ghost Alpha, and this is where the framework officially begins, probably being dragged in kicking and screaming, because honestly, that's usually how coding works. I am going to be using Unreal Engine 5.7 for this project. So, to get started, inside the Unreal Engine launcher, click on the big yellow launch button. This will launch the engine. Once the engine has launched, click the New Project button. Select the Game option. Now, select a blank project. Select a C++ project. Select the destination folder you wish to put the project into, and then enter the project name, in my case, Ghost_Alpha. You cannot have spaces in the name. Once you've verified these settings, click the Create button and allow Unreal Engine to generate the Visual Studio solution files. Once the editor opens successfully, you will now have a C++ project, and will also notice that Visual Studio or Rider has opened up with that project. I would also recommend disabling Unreal Live Coding. Go to Edit, Editor Preferences, and Live Coding and disable it. Personally, I prefer doing full recompiles through Visual Studio or Rider for larger gameplay frameworks instead of relying heavily on live coding. Also, live coding can cause file locks in your C++ project. Many tutorials begin with the Unreal first-person template, so why are we starting with a blank project? So, the reason we are not starting with the template are that the template already contains gameplay assumptions, temporary systems, hardcore logic, blueprint coupling, unnecessary dependencies, unused assets, demo content, example UI, placeholder weapons, test systems, technical debt, gameplay noise. And over time, all of that noise starts making development harder. The more unnecessary systems you inherit from the beginning, the harder the project becomes to maintain, debug, scale, optimize, refactor, network, and organize. Especially for multiplayer games, instead, we are building modular gameplay systems, reusable architecture, scalable multiplayer systems, clean gameplay ownership, professional organization, and data-driven gameplay systems. Every system should exist for a reason. Every class should have a clear responsibility, and every gameplay system should scale cleanly as the framework grows. Professional game development is largely about getting the architecture as close to correct as possible from the start. At this stage, we do not need to create every single folder right now. The goal is to understand the overall framework structure and long-term organization. Inside the content browser, we create folders directly under the content folder. We will ultimately create folders like game, players, weapons, teams, inventory, UI, audio, effects, and developer. Inside these folders, we then separate blueprints, meshes, materials, textures, animations, audio, and data. This gives us shorter asset paths, cleaner references, easier navigation, and better long-term scalability. For the C++ structure, we are not manually creating random folders first. Unreal Engine will create the folder structure as we create the classes. As we generate classes, we will place them into correct folders, and the source structure will look something like public and private ownership. Within these, we will have players, weapons, components, teams, game, UI, and framework. The important thing right now is to understand the structure and planning ahead properly. The overall goal is separation of responsibilities. Player classes will handle movement, camera, combat ownership, and interaction. Weapon classes will handle firing, recoil, ammo usage, weapon states, and attachments. Component classes will handle our reusable systems: health, armor, stamina, combat, inventory, ranking, minimap, and movement. Game system classes will handle rules, spawning, match flow, minimap rules, difficulty settings, fall damage, and progression systems. Our UI classes will handle HUD, inventory, loadouts, minimap, and respawn screens. This structure keeps the framework modular, reusable, and scalable. Now we are going to be creating the initial gameplay framework skeleton, not gameplay systems, just the architecture. The goal is correct inheritance, clean organization, scalable systems, multiplayer-ready foundations. This gives us the structure the entire FPS framework will be expanded upon later in the series. The Unreal Engine base classes we use to derive our custom classes are as follows. Our player base class derives from the Unreal Engine character class. Player and NPC classes both derive from our custom player base class. Weapon base class derives from the Unreal Engine actor class. Weapon type classes will derive from our weapon base class. Our base weapon mesh class will derive from the Unreal Engine actor class. All the component classes will be derived from the Unreal Engine actor component class. Data asset profile classes will be derived from the Unreal Engine primary data asset class. All UI widget classes will be derived from the Unreal Engine user widget class. We are building the base class structure first. Gameplay comes later. To start creating new Unreal Engine classes, select the menu Tools and New C++ class. For each class, firstly, select the correct parent class. If the class you're looking for is not one of the common classes, then select All Classes. Once you have selected the correct base class, click on the Next button. So now, ensure you have Public selected for the class type, give the correct class name, and place it in the correct folder by adding the appropriate C++ folder to the end of the path. Once you click the Create Class button, you will see the following processing window pop up in Unreal, and Visual Studio will pop up with the following message. When you see this window in Visual Studio, if you are not running the Unreal Editor from Visual Studio, you can click Reload. Otherwise, clicking Reload will stop the Unreal Editor. Remember, when creating custom gameplay classes, always make sure you derive from your own base framework classes whenever possible. For example, Player derives from Player Base, not directly from Character. This gives us centralized gameplay architecture and a cleaner inheritance long term. I have seen an issue where Unreal Engine Editor class creation window does not add in the public part to the path name. Watch for this. Ensure that the class path name is correct, otherwise your class will be created in the wrong folder. If you see this, just re-click on the private and then back onto the public, and this will add the public part back into the path for you. If you make a mistake, as I often do, and want to remove the class in error, I will usually do the following. Close down the Unreal Engine 5 editor and close down Visual Studio or Rider. Open up File Explorer and navigate to your Unreal Engine game folder. Now, navigate to the CPP file in the source private folder and delete it. Navigate to the .h include file in the source public folder and delete that. Now return to your main Unreal Engine game folder. In this folder, select the binaries and intermediate folders and delete them. If you get a folder in use error, check that Visual Studio and Unreal Engine Editor 5 are closed and not running. This is when I always had issues with live coding not releasing files. Once these are deleted, select the U project file. Right-click and select Show More Options. From the next menu, select Generate Visual Studio Project Files. This will remove and delete the files from your project. Using what we've previously covered, create the following player classes on your own. Player Base class derives from the UE5 Base character class. Player now derives from that new Player Base class. NPC Player class derives from the same Player Base class. Player Controller derives from Unreal Engine 5 Base Player Controller class. Player State derives from the Unreal Engine 5 Base Player State. This is what your Unreal Editor should now look like. Feel free to pause the video here while you complete this exercise. Once you've created the first C++ classes, you will see a folder inside Unreal Engine 5 which will say C++ classes. You can at this point right-click on that or in the subfolders and select the option for New C++ class. Also, when you've created custom classes and you want to derive subclasses from that, you can just right-click on that class inside the folder structure and select Create C++ Derived Class from this class. These will help you speed up the process of creating classes. Now, let's create the following game classes. Game Mode derives from Unreal Engine Game Mode Base. Game State derives from the Unreal Engine Game State Base. Game Instance derives from Unreal Engine's Game Instance. Player Start derives from the Unreal Engine Player Start. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. Now, we will create the following component classes. All these are derived from the same class, which is the Unreal Engine 5 Actor component class. Combat component, inventory component, team component, armor component, stamina component, movement component, ranking component, minimap component, and state machine component. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. Now we will create the weapon class framework. Weapon base derives from the Unreal Engine 5 Actor class. Weapon mesh derives from the Unreal Engine 5 Actor. Weapon static mesh derives from weapon mesh. Weapon skeletal mesh derives from weapon mesh. Bullet weapon derives from the weapon base. Melee weapon derives from the weapon base. Thrown weapon derives from the weapon base. Grenade weapon will be derived from the thrown weapon. And explosive weapon derives from the weapon base. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. Now we will create the attachment class framework. Attachment mesh derives from Unreal Engine 5 Actor class. The attachment static mesh derives from the attachment mesh, and the attachment skeletal mesh derives from the attachment mesh. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. We will now create the data profile framework. All these classes are derived from the Unreal Engine class primary data asset. Character data class, weapon data class, attachment data class, ammo data class, team data class, faction data class, difficulty data class, game type data class, rank data class, and reticle data class. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. These allow gameplay balancing without hard coding gameplay values directly into the classes. Now, we will create the UI framework. HUD widget, inventory widget, loadout widget, respawn widget, pause menu widget, and minimap widget. This is how your Unreal Editor C++ should now look. If you need a little more time, feel free to click pause now. These naming standards are things I've personally refined over several years, working with Unreal Engine gameplay systems. The goal here is consistency, readability, maintainability, and scalability. Member variables always use the M_ prefix. Local variables use the underscore prefix. Struct variables use the F_ prefix. Enums use the E prefix. Enum values use the VE prefix. Blueprint facing variables and functions should always use display names and tooltip meta tags. Large gameplay frameworks become difficult to maintain very quickly without consistent standards. Good naming conventions reduce mistakes and make large projects easier to scale long term. In part 3, we will begin implementing actual gameplay framework systems, including player base, combat component, inventory component, health systems, armor systems, stamina systems, ranking systems, multiplayer systems, weapon base and state machine. And we'll start turning the framework skeleton into a real multiplayer FPS architecture. Thanks for watching, and thanks to everyone leaving constructive comments and feedback. I genuinely appreciate it. This series is going to take time. We are building this properly, not quickly. By the end of this series, you'll understand how to structure a professional FPS gameplay framework from the ground up inside Unreal 5. And hopefully, maybe together we can bring a little bit of that gameplay first FPS philosophy back again. I'll see you in part 3.